Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be doing part 4 of Toolbox in SolidCAM 2011. In our next operation, we'll be showing you the option of ruled surface. That's a slot where one opening is narrower than the other. Here we have one wide and one narrow. If we were to open up our operation, we have our geometry. As you can see, we're using the option of ruled surface. And the geometry in this case can be picked in either direction. However, both of them have to be in the same direction. In this case, I'll be using a 10mm end mill. Of course, we have our upper and lower levels. Now, in our technology area, we have to deal with the following. Our step over, which is the step over at the widest point. We have the option of a cutting direction. We can either go along, as shown over here, or across, going back and forth, as shown over here. We have our linking, which can go either one way or zigzag, going back and forth. Of course, just as before, we have our wall offsets and floor offsets, and our extension, how much we want to extend past the part. If we run our simulation, and I'll zoom in to this area, you'll see that our tool goes across, it goes back, and it's going zigzag across, where this area over here is the step over of 2mm, because that's the wide side of the geometry. And that's how this is done. That's ruled surface. In our next operation, we'll be showing you the option of O-ring. In this particular case, we have here a tool which is narrower than the width of the area that it has to machine. The tool will go down first in the center in a helical fashion, and then when it gets to the bottom, it'll clean one side and then the other side. Let's take a look at the operation. As you can see, the geometry is the inside and the outside of the O-ring. Now, it does not make a difference which one is first and which one is second, or the direction. And as you can see, it'll first go down the middle and then clean off on the edges. In this particular case, we'll be using a 4mm end mill, our levels. And in our technology area, all we have to deal with is our rough step, which shows how much it goes down in mill, and then our finished step down, where it goes on the wall itself, how much we want it to go down each time on the wall. If we were to take a look at our simulation, you'll see that our tool goes down, and as you can see, it's going down in a helical fashion on the part itself. Then when it gets to the bottom, it cleans off the wall on either side. If we were to take this from our top view, I'll change the color of my tool pass. As you can see, the tool works first in the middle, as shown over here, and then works on the edges, as shown over here. You'll note that when it gets to the middle and finishes at the end, it radiuses into one side and then radiuses into the other side. The radius that it leads in on and it leads out on is automatically calculated according to the width left over and the radius of the tool itself. Now, in our final operation, we'll be showing you the option of clearing off the top of a cylinder. It should be noted that the home position in this particular case must be at the center of the cylinder itself, with the Z going up, the X direction as shown over here, and the Y direction as shown over here. Let's open up the operation. And as you can see, we're using the option called flattened surface on cylinder, as shown over here. We'll be using our Mac position 2. What we have to define is this one edge over here. The direction does not make a difference. So I'll be choosing this one edge as shown over here. We'll be using a 10mm end mill. Our levels up until the surface itself. Now, in our technology area, we have, of course, our step down. And what's important is our cylinder diameter. The cylinder diameter can actually be taken off the cylinder itself, and that will be automatically put into this field. We have our clear offset, which is the distance from here to here. We can simply click on the button and pick it directly off of this edge, and it measures the distance between those two edges. We have our maximum step over, and of course our extension, how much we're going past. Of course we have one way or zigzag over the parts. Let's take a look at our simulation. As you can see, the deeper it goes onto the part itself, the longer the tool pass on each level. Basically cutting only the amount of material it actually has to work over. The length of the tool path is automatically calculated according to the radius on that particular level each time. As you go further down, it gets wider and wider. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.